Today's lesson is on section 3.6, solve proportion using cross products. Yesterday, Mr. Weiner gave a nice lesson on how to write ratios and how to write ratios into a proportion problem, and then a couple methods to be able to solve those proportions. We looked at one way, which is just like solving a one-step problem to get x by itself. And then we looked at another method, or kind of introduced another method, which is solving using cross products, and that's actually one that should be a review for many of the students. I think I have seen that in 7th and 6th grade, and maybe even before. So I'm going to concentrate just more on that method today, solving a proportion using cross products using that method, because as we go on in proportion problems, or as we get to more complex ones, that's going to be the method I think that's going to make things a little easier for us. When you use cross products, and I'll demonstrate on this first example here, when you use cross products, here's what it's going to look like on a proportion problem. I have this problem here, 2/5 equals 6 over x. What I'm going to do to solve this using this method, cross products means I'm going to take the denominator of one side and the numerator of the other and multiply those together. And what I like to do when I'm showing this on the board so that you know what it looks like is I'm going to kind of loop both those things in an oval here. So 5, what it means I'm taking 5 times 6. I'm multiplying these two numbers together, and that's going to make one side of my equation. On the other side of the equation, I'm going to have the other denominator and the other numerator multiplied together. And again, actually what I like that to look like though is I'm just going to loop both of them in one big oval. So this means 2 times x. This makes the other side of my equation. Now I've just got like a one-step equation to solve, or two-step, or whatever it may be. But when I use cross products like this for a proportion problem, as you can see, it sets up an equation, and we've solved equations the last 4 or 5 sections in a row. So I feel like if we can set up some kind of equation like this, be it multi-step, one-step, doesn't matter. If we can set up some kind of equation like this, I feel pretty comfortable, pretty confident that we can solve this kind of problem and find out what x is supposed to be. So in this problem, 5 times 6 would give me 30 on this side of the problem. On the other side, I still just have 2x. If I divide both sides by 2, just like we would in some other kind of problem, to get x by itself, I would get x equals 15. So again, that's just one way I can solve this proportion problem. There are other ways too, but I'm going to concentrate on just the cross products method today because that one will help us solve much more complicated ones as well. Okay. Again, demonstrating me on one more simple problem for cross products. This example right here, if I'm going to use that method to solve a proportion, it means I'm going to take 8 times 5, and that's going to be one side of my problem. So I can just write 8 times 5, which is 40 right away. So that gives me 40. On the other side of the problem, I'm going to take 1 times x, which is really just 1x, I guess I could write, but it's really just x. And so this problem actually is already solved. So this is x equals 40. And so that's but that's really what's happening when I'm solving something using cross products. Okay. I take this proportion, and really what I'm doing is I'm making kind of a new equation. And I'm just saying this denominator, the blue ones, 8 times 5, that multiplied together is equal to the green ones, 1 times x, that multiplied together. And this makes my new equation, and then I can solve that equation if it takes a few steps or not. So. Well, as I talked about above, I'm concentrating just on this method today to solve a proportion problem because it'll help us solve ones that are a little more complex. For example, these ones that I have on the board now. So these are just below those first problems. So again, we talked about solving cross products up there, or using that method. We're going to do the same thing down here, but now notice that I have a little different terms in these problems. Like I have 3x. As opposed to just x by itself, I have 3x or 4x in these problems for my variable. So my variable is not alone, actually. There's some coefficient with it that's not just 1. So that's going to make this problem just a little different, but as you'll see, if I use cross products and set up some kind of equation, it can still be a nice, just like a 1 or 2 step problem that I can solve easily, just like we've done earlier in the chapter. So again, this problem says solve. So what I'm going to do is I'm going to use the cross products method. I'm going to take 7 times 6, and that's going to be one side of my equation. So actually, I'm just going to jump right to that. 7 times 6 is 42. If you're doing this problem in your book, or just say this is the book problem, again, when you're doing these problems for your homework, you don't have to rewrite the problem. You can write exactly what I'm writing down on this side. This could be what your notebook looks like. You could take 7 times 6 and just write down 42 in your notebook right away, and then say that equals, and then, well, 2 times 3x. What does that give me? Well, 2 times 3 gives me 6, and then the x comes along with it, so 6x. So this, again, over here, if you're doing the problem from the book to your notebook here, this could be what you write down in your notebook on this side. So you don't have to recopy the problem. So in this problem, though, I have 42 equals 6x. So again, now I've just set up something that's a one-step problem. Divide both sides by 6, and I'm going to get x equals 42 divided by 6 gives me 7. So x equals 7. Again, nice thing about a proportion, just like with the other equation problems, I could even plug 7 back into the proportion and see if it makes it true, or see if I get the same thing on both sides. On this side, my checking to see if this is the right answer. I have 2 over 7, which equals, well, 6 over, well, 3 times 7 gives me 21. And I have to check and see, are these ratios actually equivalent? Are they equal ratios? Well, if I look at this one on the right here, 6 over 21, I can divide each of those numbers by 3. So divide by 3. Divide each one by 3, and what does that give me? Well, that gives me 2 over 7. So what do you know? Yes, it is the same as the left side, so those ratios are equivalent. So again, nice thing about a proportion problem, just like with any other equation, we can always check our answer by plugging it back into the original equation, see if it is the correct answer or not. Going to this next problem here, we'll just look at this one. We'll worry about the one below that, but let's look at this problem. Again, I'm going to solve it using cross products. I'm going to take 5 times 18, and that's going to be one side of my equation. 5 times 18 gives me 90. That's going to equal whatever I get when I cross multiply the other way. 3 times 4x, well, that gives me 12x. And now I've just got a one-step problem I can solve. Divide both sides by 12. 12's cancel out on that side. I get x equals 7.5. And again, I could plug that back in and find out that if it's the correct value for x, but by plugging it back in, I think you would find that it also does check out. So that is the correct answer. Well, again, using cross multiplication to solve these proportion problems, we're doing this and concentrating on this today because we can run into some more complex problems. This one right here I have on the board now, this example, is a little more complex than the ones we've been seeing. Because now also notice, well, I have x in this problem, but I also have this expression over here, x minus 6 in the denominator of this ratio. So now I have some kind of expression. I don't just have like a term. This is actually 2 terms now, x and 6. I have 2 terms here in the denominator of this ratio. So something a little different is going to happen when I cross multiply. Do realize though that this is just some number. So when I multiply something to it, I have to kind of keep that expression together. We'll talk about how to do that in 1 second here. But let's start this problem off like we're doing the things that we would know how to do. I would start by cross multiplying. This is some kind of proportion problem. I'm trying to solve it. So I would start by multiplying 2 times x. That would give me one side of my equation. That's just 2x. When I look to multiply the other sides together, the other denominator and numerator, I have 3 times, and again, as I talked about, this right here, this expression, x minus 6. Just remember that I don't know what x is, but let's say it was some number like 9 or some number like 12. You know, I could put that in there and take that number minus 6, and I would get an answer. I would get a value, like let's say 3, or let's say 4, some kind of number. So what I'm trying to do is I'm saying take this 3 and multiply it times whatever I would get for this answer. How do I show that in my equation? Well, that means I take 3 times not just x or not just 6, but it means I have to take it times this whole expression, because this expression will end up being some number. And so I have to take 3 times whatever that is. So I have to keep that in parentheses. That is some number. 3 times whatever this number, x minus 6, whatever it ends up being. So here's what this should look like on the right side. I have to keep that little expression in parentheses. 3 times whatever x minus 6 ends up being. That's how I show that in my equation. Hopefully now this looks a little familiar. Again, here's why we've shown how to use cross products today. Because when I do this, now I've just set up a multi-step problem. And we did a bunch of those as in this chapter so far. On the left side, I just have 2x. On the right side, I have 3 times in parentheses x minus 6. If we're solving some kind of equation we've talked about forever, or for at least last month here or so almost, that the first thing I'm going to do is look to distribute. So if I can take 3 times x and 3 times negative 6, that's the first step that I want to do in this problem. On the left side, I still have 2x. On the other side, I have 3x minus, well, now 18. Now that I've done that, our next step, we distribute if we can. Remember, we collect like terms, step 2 if we can. Step 3 now is get the variable all on one side. So I already have negative 18 on the right side over here. So what I want to do is maybe get all the x's to the left side. So let's subtract 3x from this side. And whatever I do to one side, I have to do to the other side. So I have 3x minus 3x. These will just cancel out like we've done many times before. On that side, now I just have negative 18. 2x minus 3x just gives me negative 1x. And we've talked about a couple ways I can solve this problem, but I'll just do it this way in this case. Since I have the negative 1 with x, whatever number with x there multiplied, I want to divide by to get rid of it. So I'm just going to divide both sides by negative 1. Negative 1 divided by negative 1 will just give me x alone on this side. Negative 18 divided by negative 1 just gives me positive 18. So positive 18 for my answer. Looking at another example like the one we just did above. Here again I have a proportion problem, but now again I have some kind of expression here in my numerator of this ratio. So I'm going to have to keep that in mind when I'm cross multiplying, that this 2x plus 5, it would stand for some number. So I have to consider that I'm going to take 3 times whatever that whole expression is. And again, I'll show you how to do that in your equation here in just 1 second. First, I'm going to start by cross multiplying this other side. And again, it doesn't actually matter which side you put on the left or which side you put on the right. So I can start with the 7 times x in this case and put that on the left side of my problem. So that would just be 7x. But it really doesn't matter what's on the left and what's on the right. I'm just the fact that I'm making an equation with what I'm cross multiplying. When I cross multiply here 3 times 2x plus 5, again, this means 3 times whatever this number ends up being, 2x plus 5. If I put a number in for x and evaluated it out, I'd get a number. And what I'm saying is, once I get that number, I would want to multiply it by 3. So I have to do all that stuff first. So I have to keep it in parentheses and then multiply it by 3. So that's what it looks like in my equation. That expression by itself, 2x plus 5 in parentheses, that times 3. Once I've got that set up, now I can solve it just like any other equation, like we've done, or the multi-step equations like we've been doing recently. First step, if I can, is distribute. So I'm going to take 3 times 2x, which gives me 6x. 3 times 5 gives me 15. On the other side here, I still just have 7x. And now I just got to get all the x's on one side, subtract 6x from both sides. When I do that, all that's left on the right side is 15. All that's left on this side is just 1x, or that's just x by itself. So there it is, x equals 15. I'll do one more example of cross multiplying with one of these more complex problems. So again, if I'm going to cross multiply, it means I'm going to take the denominator of this side and the numerator of this side and multiply those two together and get 8x. That's going to be one side of my new equation. There's my equal sign to show I have an equation. So 8x equals, well, whatever I get on this side, it's going to be 4 times this expression, x minus 3. And again, that's going to stand for some numbers, so I have to keep that together. I would want to take x minus 3 and then multiply it by 4. So I have to keep the x minus 3 together in parentheses. That says I'm going to multiply or subtract those first, figure out what that answer is, then multiply by 4. That's what I need this to look like. Good. Once I've got the equation set up, now again going through my multi-step steps, I would distribute first when I can. 4x minus 12 on this side. On the other side, I just have 8x. I'm going to subtract 4x from both sides in this case to get all the x's on one side. That'll get rid of 4x from over here. On that side right now, I just have negative 12. Remember, that subtraction sign stays with the 12 because that's the sign in front of it. So negative 12 on the right side. On the left side, I just have 4x. Divide both sides by 4, so x equals negative 3. So again, today just concentrate on solving using cross products, because that method will get us through a bunch of even these different complex type of proportion problems. So if we concentrate on this method, I think this method alone will get us through many of these types of problems.